welcome to this episode of Night Sky News for March 2024 with me, astrophysicist Dr. Becky Smethurst. This is the show where we chat about what you should look out for in the night sky in the next few weeks, and then we chat about what's been happening in space news in the past few weeks. In this month's episode, we're chatting about how you can watch the solar eclipse on the 8th of April across North America, the possible cancellation of a next generation ground-based telescope, and the fastest growing supermassive black hole that's ever been found. There's chapter markers down here if you want to skip ahead to any specific news story, plus any scientific research papers I mention are all going to be linked free to read in the video description down below. And yes, for all of you wondering, I did move house, and no, I don't have any furniture for my new office just yet. This is all temporary for now, but I'll get there eventually. Anyway, without any further ado, let's kick things off and start by looking up. All right, let's start with something to look out for in the evening sky wherever you are in the world, because on the 24th of March, the very bright Jupiter will be visible along with sort of that like sunset glow towards the west, along with Mercury, just below it, a lot closer to the horizon. Now, it will be a lot harder to spot Mercury than Jupiter, because Mercury is so much fainter than Jupiter, and it's close to the horizon, so you're competing more with that sunset glow, which is why it helps to have Jupiter there as sort of like a signpost of where to look. And the 24th really is the best day to try and do this, because it's when Mercury reaches something called greatest eastern elongation. Essentially, on their orbits, Earth and Mercury make a right angle triangle with the sun, meaning that from our perspective here on Earth, it's the furthest it gets from the sun, and therefore the highest that Mercury rises in the sky, giving us the best chance of spotting it. If you're struggling to find it with just your eye, don't worry, it is very faint Mercury, it's difficult to spot. So maybe try taking a picture with your smartphone, see if that manages to pick it out and you can find it on the image, and then again, it'll make it easier for you to know where to look in the sky. It is very close to the horizon, only 10 to 15 degrees above it, which is about the distance between these two fingers held at arm's length, so it's not that high in the sky. Plus, this will be easier to spot if you're in the northern hemisphere as well. It just won't rise as high in the southern hemisphere at this time of year. Then as we move into April, we've got something to celebrate, because my favorite planet Saturn is back in our morning skies. And particularly on the morning of the 6th of April, before sunrise, it will make a triangle with Mars and the crescent moon, aka the toenail moon, my favorite moon phase. Saturn will look fainter and yellowish, and Mars slightly brighter with that classic reddish tinge. The further south you are, the better for this. The trio will rise much higher in the sky before the sun does. You might even catch the very bright Venus rising behind them. And if you have clear skies again the next morning on the 7th, the toenail moon will then be closer to Venus. However, here in northerly latitudes, we are going to struggle to see this because of the angle of the plane of the solar system to the horizon at this time of year. So they've only just really snuck over the horizon before the sun rises behind them. So sadly, I won't get to see this pairing of my favorite planet and my favorite moon phase from here in the UK. So if you do get up early and manage to snap a picture of this from wherever you are in the world, send them my way over on social media, because I'd love to see them. Then on the 8th of April, we have the total solar eclipse that's visible across Mexico, the USA, and Canada. If you live anywhere along this red dashed line, then you will get to see the moon completely block out the sun for around about 3 to 4 minutes in the afternoon on Monday, the 8th of April. If you're in the shaded yellow regions on this map, you'll see a partial covering of the sun. It'll kind of look like the moon's just taken like a little bite out of the sun. Here's a more detailed map from NASA with timings and cities labeled, which I'll link in the description below, but I'll also link the time and date website where you can put in your location and it'll tell you what you'll see from there and at what time to look as well. Plus, I'll also link this map from the Eclipse company, which also labels communities with eclipse events across the US to help you make plans for how to see the eclipse. For those of us outside North America, we're gonna miss this one sadly, but if you are in Iceland or Ireland or the western edge of the British Isles, you will see a partial eclipse at sunset if it's clear, which is always great fun to see. As for watching the eclipse, do not look at the sun with just your eyes, you will damage them. Don't do it even in sunglasses. It's not worth it, you'll cause permanent damage. You can get special eclipse glasses to watch eclipses that filter out over 99.999% of the sunlight, and only then is it safe to look at the sun with them. These will sell out fast though, because they are like the most immersive, natural way of viewing the eclipse. So if you do want some, try and get your hands on some sooner rather than later. You might still have some like stashed in a drawer from like the 2017 eclipse that happened a couple of years ago. If you do find them in a drawer, please, 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 please hold them up to a light in your house to check them for scratches before you use them during the eclipse and look at the sun. Again, if you don't do that, you will cause permanent damage to your eyes. If you can't get your hands on eclipse glasses, you can always make a pinhole camera, which I'll pop a link in the description down below on how you can do that. Or you can hold up a colander over your shoulder, like a vegetable strainer, and the image of the eclipse will get projected down through the holes of the colander onto the ground or onto a piece of paper if you hold one up. That's a really fun one to do if you can only see a partial eclipse in your area, because you'll really be able to see very clearly that little bite that the moon has taken out of the sun. Now, as always, eclipses come in pairs. There's always a lunar eclipse where the Earth passes in between the moon and the sun that goes hand in hand with a solar eclipse where the moon passes between the Earth and the sun. This time, it's nothing to get excited about, sadly. So 2 weeks earlier, on the 24th of March, there will be sort of like a penumbral lunar eclipse that's visible again across the Americas, which just means the full moon will just look slightly darker than usual as it passes into sort of like the edge of the Earth's like fuzzy shadow. Last month, I also said I'd update you about Comet Pons-Brooks, which is getting closer to the sun and to Earth all the time, so is getting brighter. Could become bright enough to see with just your eye and maybe even visible during the eclipse as well. Its magnitude right now is around about 5.3, which means it is technically bright enough to be seen with just your eye in the darkest of skies where there's like no light pollution whatsoever. But for the rest of us who realistically, like, we do live in light polluted skies in suburbs and cities, still gonna need binoculars or to take a picture with either your smartphone or your camera to be able to spot this. There is a chance that it'll get brighter, but to quote my colleague, Dr. Robert Massey, comets are like cats. They have tails and they're very unpredictable. So it could do anything, but I don't think it's gonna get as bright as, say, for example, Comet Neowise back in June 2020. You know, back then you just had to take any non-astronomer who just, randomly wandered out of a pub, point them in the right direction, and they'd be like, oh, hey, what's that fuzzy spot? It did get bright enough for that. Whereas this one, I think you're gonna need to know your way around the sky a little bit to be able to find it. But having said that, I've got another planet signposting opportunity for you to spot it. Because on the 10th of April, just before sunset in the west, Jupiter will pair up with both the crescent moon, and then just below it will be Comet Pons-Brooks. So this will be a great opportunity to easily find the comet if you haven't spotted it yet, but also a great astrophotography opportunity as well. Because not only is Jupiter nearby, but Uranus is too, just above Jupiter. So you might actually be able to get all 4 objects in one long exposure image. If you've never tried taking pictures of the night sky before, check out my previous video on tips for astrophotography for both smartphones and cameras. And as usual, if you snap any pictures of the comet, send them my way over on social media. Now, you might have seen some coverage of Comet Pons-Brooks visibility in the news in the past few weeks. And while space news might not always dominate the headlines, it's effortless to stay informed thanks to the sponsor of today's video, Ground News. Their app and website shows you all the world's media in one place, so you can compare coverage to see the full picture. And it's the brainchild of ex-NASA engineer Harleen Kaur. Look, with general elections coming up in both the US and UK later this year, getting news that is free of bias and also ad-driven algorithms online is crucial. Ground News' election page is tailor-made for this purpose. It curates stories relating, in this case, to the US election, and allows you to filter them on topics that are important to you, like the environment, for example, ensuring that you're equipped to make informed choices during the election. And Ground News highlights stories that otherwise might have been overlooked, such as this story on how methane emissions from the energy sector rose in 2023, with over 20 different sources at your disposal. Here you can see there are only 21 81% are from right-wing sources. So if you only tend to read right-wing publications, you might have missed it. And what I love about ground news is that you can get quick access to the international perspectives from sources like El País and The Hindu. So lately I've been using ground news to get really well-rounded perspectives on important topics, and it's why I'm really excited to be partnering with them again to help you do the same. So head to the link in the video description below at ground.news/Dr. Becky or scan the QR code to get 40% off their Vantage plan to get unlimited access. That link obviously supports my channel, but it also helps to maintain this transparency in the media. So thanks again to Ground News for sponsoring this video, and now let's chat about what's been happening in space news in the past month. First up, NASA have launched a really fun new tool that I wanted to flag. It shows you what the Hubble Space Telescope and the James Webb Space Telescope are observing right now. You know, there's been the odd Twitter bot over the years that scrapes NASA's website to do this, and of course NASA publish the observing plan each week on their website, but it's not exactly the most human readable thing you've ever seen. I'm sure user interface designers everywhere are just shuddering looking at that. But now NASA have released this nice graphical user interface where you can see the current observation and see what proposal it came from as well to read the science case for why the observation was done. If you've been watching my channel for a while, you'll hopefully recognize these PDF files because I try and show them as often as I can, you know, just to highlight the process that is involved with doing this kind of science. There's one tool for the Hubble Space Telescope, there's one tool for the James Webb Space Telescope. I'll link them both in the video description down below if you want to have a play around. Now, I couldn't let this night sky news go by without mentioning Intuitive Machines' Odysseus rover, which landed near the south pole of the moon on the 23rd of February 2024. Here you can actually see it in imagery taken by NASA's Lunar Reconnaissance Orbiter that's in orbit around the moon at an altitude of around 50 kilometers. You can see the before and you can see the after landing. Now, this is the first time that a US-made craft has landed on the moon since 1972 with Apollo 17. And more importantly, for the sort of context of the history of space exploration, it is the first time that a commercial company has landed a craft on the moon, or any other object in space for that matter. In terms of milestones, I think it's similar to the first commercial satellite, Telstar 1, that was launched in the 70s, or SpaceX's Crew Dragon being the first commercially developed craft to take astronauts to the International Space Station back in 2020. In terms of scientific benefit of a mission like this, NASA actually purchased room for 6 instruments on board the Odysseus rover, one of which is a radio light detector that detects whether human or natural radio frequencies near the surface of the moon actually interfere with any science that's conducted there. Plus there's a CubeSat on board that's testing a new way of navigating around the moon. So you can really tell from sort of those instruments that NASA has on board, that their focus really is looking towards the Artemis missions to put humans back on the moon, but also that end goal of maybe getting a moon base that's inhabited by humans at some point in the near future. And I think it's really interesting to think how commercial space companies are really going to contribute to that goal and other future space exploration missions, doing the grunt work of launching and providing the spacecraft, leaving NASA and ESA and other space agencies to focus on the science side of these missions, which is an exciting thought because I'm not really that thrilled by the idea of sending humans back to the moon if you think of it in terms of a cost and risk versus scientific reward sort of argument. But if we think about the fact that, okay, the commercialization of space exploration will make space exploration itself cheaper in the long run, then I am excited for the missions that it might make possible. There are so many scientific missions that get pitched every single year that just get left by the wayside because space agencies only have a certain amount of funding. So for example, if we want to go back to Uranus and Neptune that we haven't visited since Voyager did back in the 70s, or to specific moons of Saturn or Jupiter that are of great interest in terms of astrobiology and habitability. So we could see missions to places like those in the solar system happening in the near future, finally, after being overlooked for so long in favor of other missions that got funded instead. So, more commercial activity should make exploration cheaper in the long run. So if that leads to more science getting done, then I definitely think this milestone is something to celebrate. Something not to celebrate now, though, because the National Science Foundation, or the NSF in the USA, have essentially been given an ultimatum and been told that they have to choose which of the next generation ground-based telescopes they want to continue to fund. Either the Giant Magellan Telescope, the GMT in Chile, or the 30-meter telescope, the TMT in Mauna Kea in Hawaii. Essentially, its budget has been capped by Congress, and now it can only afford to continue funding one of them. That's despite the fact that telescope parts have already been manufactured for both telescopes, and construction has even started for GMT. Now, you might be thinking, okay, well, these telescopes are giant, right? They're 25 to 30 meters across in terms of their mirrors that collect the light. Why do you need two of them? Well, the point is that you have one in the southern hemisphere and one in the northern hemisphere so that you can cover the entire sky. Plus, the bigger the telescope, the better the resolution. So the smaller the thing that you can see on the sky, which means that you can resolve things at much greater distances away from us. And it means that these telescopes in the planning would have had around about 10 times the resolution of the Hubble Space Telescope and 4 times the resolution of the James Webb Space Telescope. So people are very excited about these telescopes, right? Because they really are set to revolutionize how we do ground-based astronomy. They have spectrographs on the telescopes as well, which is where you can take the light and split it through a prism to get a trace of how much light each wavelength you receive, which is sort of like a fingerprint of the object that you're looking at that gives you so much information. So they really are a key tool to following up the things that we find in the next generation big surveys that we're doing from the ground that just take lots of images. We find lots of things in those surveys, but then we need to follow them up with these big telescopes. But of course, with all projects like this, it's not just the science that informs the design and the planning decisions. It's politics too, because there's funders and government agencies involved. So the location of Chile in the southern hemisphere for the GMT, the Giant Magellan Telescope, was a no-brainer, right? It really is the best site in the world to do astronomy from. It's in the middle of the desert, so there's no humidity that interferes with your observations. It's incredibly high altitudes, there's a lot thinner atmosphere, and it's really far away from light pollution because it is incredibly remote. But the European Southern Observatory, ESO, is also building the European Extremely Large Telescope, the EELT, in Chile, which will have a mirror 40 meters across. So it's much bigger than the planned GMT, which is about 25 meters across. And it's also much further along in terms of construction, so it will be complete well before GMT. To put it bluntly, GMT really is no match for ELT in terms of scientific capability. Then the location for the 30-meter telescope, the TMT on Mauna Kea in Hawaii, is a little bit more controversial. Yes, it makes sense in terms of the science because Mauna Kea is one of the best sites in the northern hemisphere to do astronomy from, for all the same reasons that we talked about before in terms of altitude and remoteness. It's away from light pollution, although as the population of Hawaii grows, that does start to become a little bit more of a concern. But really, it was motivated by politics because the TMT is part funded by the National Astronomical Observatory of Japan. So finding somewhere halfway between the USA and Japan made a lot of sense. But the mountain of Mauna Kea is a hugely important environmental and cultural site. There are some native Hawaiians that consider the mountain to be sacred. And there's been a lot of opposition to the TMT's construction for that reason. I mean, native Hawaiians just seem to have been ignored in all of the decision-making process by big government agencies. And due to ongoing protests, the construction of TMT has been halted for the past 9 years. And really, all of this could have been avoided if the island of La Palma in the Spanish Canary Islands just off the coast of Africa had been chosen as the site of TMT, which is also an excellent site to do astronomy from in the Northern Hemisphere. And like Mauna Kea, it already has the infrastructure on there with, telescopes already built, but it's not a culturally important site. Of course, I'm sure you can imagine the politics headache that would have come from building a joint US and Japanese funded telescope on a European site. So US astronomy really has been playing catch up with the rest of the world for a long time now because of the delays on both of these projects. So I think some people saw this sort of ultimatum that NSF has been given as a bit of a relief, because then at least one project is likely to move forward. It's just which one. Now it's likely to be the Southern Hemisphere GMT, since there's no opposition to the construction, it's smaller and cheaper, and 3 of the 7 mirrors that make up the main telescope mirror have already been made. So it's the low risk option. But if we're talking about which one's more useful scientifically speaking, it would be the Northern Hemisphere TMT, because that could still pair up with ESO's ELT in the Southern Hemisphere to cover the whole sky like originally planned. So I'm sure there will be some people still arguing in favor of funding the TMT, maybe even moving its location from Mauna Kea so that construction can go ahead. But either way, whether you fund the GMT or the TMT, the future of US astronomy is going to take a hit. Like with this decision, you are in some way going to restrict the access of astronomers and astrophysicists working at US institutions to that sort of cutting edge of, future ground-based observatories. So I really don't envy NSF for having to make this decision, and it really does feel like a lose-lose situation. And NSF weren't the only ones announcing budget cuts this month either, because NASA announced its 2025 budget request this month, and it included a cut to the Chandra X-Ray telescope budget, which essentially means they're going to start phasing out that telescope, despite the fact that it is working absolutely fine and is still giving us incredible scientific discoveries. They will essentially shut it down prematurely before its replacement is due to launch in about 10 years' time. And let's face it, that's also probably going to be pushed back. So it's a really baffling decision to both me and a lot of my colleagues. It's the only high-resolution X-ray telescope we have, and it's crucial for follow-up for things that we find, say with Hubble or with the James Webb Space Telescope, especially in terms of high-energy astrophysics, if you want to study things like black holes and neutron stars. And so without Chandra, I think the field is really going to suffer. But let's talk about something cheerier now, like the fastest growing supermassive black hole that we have ever found. The discovery was published last month by Wolf and collaborators, who claim to have found a black hole 17 billion times more massive than the sun, which is growing, so taking in 1 sun's worth of material every single day, not year, day, which makes it the brightest object that we know of in the entire universe, what's known as a quasar. And I know what you're thinking. How in the universe did we only just find the brightest object in the entire universe? Surely that must have been very hard to miss. Well, because the gravity around supermassive black holes is so strong, the material that spirals around that black hole, which will eventually become part of it and grow its mass, gets accelerated to such huge speeds that it gets superheated to very high temperatures, so much so that it glows across the entire spectrum of light, from X-rays to visible light to the infrared. They get so bright that they can outshine all of the hundreds of billions of stars that make up the galaxies that they're found in the centers of. And when they're at really large distances, that's all we see, and it's how quasars got their name: quasi-stellar objects. Things that look like bright stars, but aren't. And then eventually over time, quasi-stellar object got portmanteaued to quasar. And it was really the launch of the Hubble Space Telescope back in the early 90s that revealed them for what they were. Because although they looked like bright stars, when we finally had a telescope with the resolving power to see very small things at great distances, you could actually resolve the galaxy of stars around these bright quasars as well. And then when you can actually take a spectrum of the light from the quasar, so when you take it, split it through a prism and get a trace of how much light of each wavelength you receive, you get a very different pattern of light for a star than than you do for a quasar, which is what reveals it as a growing supermassive black hole. But what it means is that even now, as we search for quasars in data from these telescopes that do these huge surveys of the entire sky, we're still looking for things that sort of look a bit like stars. And so now we're in the era where we train, sort of like computer algorithms, a machine learning algorithm to look for things that look like stars but aren't, based on what we've seen before, based on the quasars that we found before. But what that means is that if you do have a quasar that looks ever so slightly different from the norm, i.e. it's a lot brighter, perhaps, then those algorithms are going to skip over those objects and probably label them as stars that are much closer to us in our own galaxy. And that's exactly what happened here. A quick automated pass over data from the European Space Agency's Gaia satellite passed over this quasar J0529-4351. But thankfully, it was then found in this work from last year by Onken and collaborators, who knew this was an issue and specifically searched for these brighter quasars. And they noted specifically that this quasar, J0529-4351, was particularly bright, especially considering the fact that the light had taken 12 billion years to get to us. So it was at such a huge distance, and even then looked bright, then it would be the brightest thing that we had ever seen. But there was follow-up data needed to confirm its properties first, which is where we are now with this paper by Wolf and collaborators. Now, the first thing they had to do was confirm if the light from the quasar had actually been magnified by a gravitational lens, and that's why it looked so bright. So this is when there's a galaxy in the foreground, sort of photobombing the light from the quasar, which bends the light due to its strong gravity, acting like a lens, and makes the quasar in the background look brighter than it actually is. This is actually what was responsible for the brightness of the previously known brightest ever quasar observed by the Hubble Space Telescope and reported by Fan and collaborators back in 2019. But for J0529-4351, Wolf and collaborators couldn't find any evidence of gravitational lensing, suggesting it really was that bright. So they then applied for follow-up observing time with the X-shooter spectrograph on ESO's Very Large Telescope, the VLT, in Chile to get a spectrum. With this, you can then observe emission from certain molecules that's unique to that molecule, like, for example, carbon, silicon, and oxygen that are spiraling around the supermassive black hole. They should all be given off at a single unique wavelength for each molecule or element that gives you these big single spikes in the spectrum. But when you look at the spectrum from this quasar, you'll see they're much broader than that, because the light is getting Doppler shifted because it's orbiting around the black hole, which is what broadens these features. And if you can measure how broad the feature is, you know how fast the material is moving, and therefore you can measure the mass of the thing it's moving around. So Wolf and collaborators fit a model to all of the data that they had, so the total brightness in the images and the shape of these emission features in the spectrum, to get at a few properties of this quasar, including a black hole mass, an inclination for the disk of material, the spin of the black hole, and its growth rate. This is how they determined that this is a black hole between about 15 to 19 billion times the mass of the sun, growing at a rate of 370 suns worth of matter every single year, or around 1 sun's worth of matter every single day. It's just absolutely mind-boggling. I just want to get across, how crazy that number is. The typical, nearby quasars that I deal with in my research, they have a range of accretion rates from, growth rates from 0.1 to 1 sun's worth of matter every single year. Not day, like this quasar. It is absolutely incredible. To be accreting, taking in that much matter, the disk of material spiraling around this black hole has to be absolutely huge. A back of the envelope calculation puts it at around about 7 light years across. For context, you know the famous first ever image of a black hole showing M87's accretion disk in radio light? That is only 0.013 light years across. This quasar's accretion disk is about 500 times bigger than M87s. You know, it's something like 15,000 times the distance of the sun to Neptune. So like it's the kind of numbers that make even us astrophysicists that deal with big numbers every day just stop in our tracks. So as you can imagine, there's a lot of excitement around this object, and I think there's going to be a lot of follow-up observations proposed for it as well, especially using the VLT in Chile. One of the instruments called Gravity Plus can actually resolve the accretion disk in fine detail to directly measure the black hole mass, rather than measuring it just through kind of like an indirect method that we know is correlated with those emission lines like Wolf and collaborators did. And bright quasars allow you to measure the expansion rate of the universe out to huge distances, well beyond what's possible with like supernova or Cepheid variables like we talk about all the time on this channel when we discuss like the Hubble tension or the crisis in cosmology. But to do that, you need incredibly stable repeat observations of a set of quasars, which is going to be a job for the European Extremely Large Telescope when that comes online in the future as well. So there's a lot of current excitement about this quasar, this fastest growing supermassive black hole that we've ever found. But I think there's going to be a lot of future studies to look forward to as well. So make sure you're subscribed so you don't miss out. All right, that's it for this month's Night Sky News. I know I didn't even have a chance to chat about JWST's incredible possible discovery of population 3 stars. These are the first generation of stars to have formed in the universe, and detecting them has always been a major goal for JWST. So I think I'm going to have to devote an entire video to that, which will be out next week. So look out for that one. Before I go, I also want to give a shout out to a book that I think you guys will love. It's called The Accidental Universe, and it's written by my colleague Chris Lintott, and it's out in the UK on the 21st of March. I was sent an advanced copy and it is fantastic. It's essentially all about like the accidents and human error that led to like major discoveries in astronomy, whether that's like asteroids or pulsars or even like claims of alien life. Honestly, it is so much fun. It's fantastic. I think you will love it. I'll pop a link in the video description down below if you want to grab yourself a copy. As always, if you snap any pictures of the night sky, then send them my way over on social media. And of course, any space news stories that you see that you want me to explain in a future Night Sky News episode. But until next time, everybody, happy stargazing. First video in the new space. Any scientific research papers I mention are all going to be linked free to... Oh, wow, there was a cool red kite just flew over through the skylight. That skylight's going to be so distracting. And yes, for all of you... it is going to be very close to the horizon. If you're struggling to find it with just your eye, don't worry, it is very faint. It's hard to spot Mercury. So try taking a photo. Monday, is it Monday? I should check that while I'm here. I've just sort of... It is Monday. Or you can get yourself a colander. Should I go get the colander from downstairs? Plant's kind of blocking the door. Can't I be bothered? People know what a colander... I'll just show a picture of a colander. It's fine. Light polluted air... Oh, that's a doorbell. The doorbell is a delivery of my new salopettes when I go skiing. Do you want to see? Because I'm in love, so. I mean, I've not tried them on yet, but like, how cool the colour is. That's like a little minty, sagey green. And they're bib, like, dungaree salopettes as well. So excited. Sorry. Science. When we had the resolving power of the Hubble, another kite went past and I got distracted by it. Sorry. They're so cool. They swoop so low. I think looking for like a roadkill and stuff, but 05294351, 05294351. And they noted that this quasar J0529-432, 5294351. And they noted specifically that this quasar J0532-4, no, 0529-4351, 529-4351, 529-4351. And they noted specifically that this quasar J0529-4351, I actually got that right that time. I wish I hadn't. And bright quasars allow you to measure the expansion rate of the universe out to huge distances, well further. It's like teenage years coming out. Well further than you can do it with supernova. I think that's everything. I think we're done. Win.